In example 3, we're going to look at partial fraction decomposition that includes some irreducible quadratics. If I take a look at this x squared minus x plus 7, my first job would be to see if I could factor it. When I realize I can't factor it, that means I have an irreducible quadratic. This one, x minus 1, is a linear factor. This is a quadratic factor. It comes from inside the parentheses. This x is being raised to the first power, where this x is being raised to the second power. The difference in writing these, any linear factors just have a letter on top like we were doing before. So my x minus 1 I would have as a over x minus 1. But my quadratic factors, I'm going to have something with an x in it. So I'm going to have bx plus c all over my quadratic, which is x squared minus x plus 7. So notice a linear factor, you just have a letter on top. A quadratic factor, you're going to have something times x plus something else. Okay, and it doesn't have to be a b and a c. It could be ax plus b. It could be cx plus d. But you're going to have something times x plus something else. Then solving it is just the same as before. We're going to go ahead and multiply by the least common denominator. And in this problem, our least common denominator is x minus 1 times x squared minus x plus 7. So if I take this left-hand side of my equation and multiply it by my least common denominator, this denominator here will cancel out with this right here, leaving me with just x squared plus 13 equal to, if I take a over x minus 1 times my least common denominator, the x minus 1 and this x minus 1 will cancel, and I'll get a times x squared minus x plus 7. And then if I take this part times my least common denominator, the x squared minus x plus 7 and this x squared minus x plus 7 will cancel, and I'll be left with bx plus c. Now I have to put that in parentheses because it's that whole thing that's getting multiplied by x minus 1. Then I need to go through the algebra steps, get rid of those parentheses, and multiply everything out. So I have a times x squared, which is ax squared. Then a times negative x is a minus ax. A times 7 will give me 7a. Then multiplying out over here, I get bx times x, which is bx squared. Bx times negative 1, which is a minus bx. C times x, which is cx. And c times negative 1, which is negative c. Then I'm going to do what I was doing before, where I'm going to group together my x squareds, and I'm going to factor that out right away too, so I can save myself a step. So here's my x squared. So I'm going to take that x squared out in front, and that's left with, oops, let's make that a little bit nicer. That gives me an a plus b inside. Then I'm going to go ahead and find all my x's. So I have a negative ax, a negative bx, and a positive cx. So I'm going to take out that x, and I have negative a minus b plus c. And then I'm looking for my constants. So I have that 7a and that minus c. And I'll group those together. So 7a minus c. Then what I need to realize is that I have my coefficients. So right here, my a plus b, that's my coefficient of my x squared term, which this x squared term has a 1 in front of it. So I can say that 1 is equal to a plus b. And then I can take a look at this part right here. This has to be the coefficient of x. Since there's no x over here, that means the coefficient of x is 0. So I know 0 is equal to negative a minus b plus c. And then I have my constant. My constant here is 7a minus c, and that has to be equal to that 13. So I can say 13 is equal to 7a minus c. Then I want to go ahead and solve my system. So I'm going to move up so I have a little bit more room. I'm going to go ahead and take the first two systems, these two right here, and I'm going to add those two together. So I have 1 equal to a plus b and I have 0 equal to negative a minus b plus c. 1 plus 0 is 1. A plus negative a, that's going to cancel out. B and negative b will also cancel out, and I get 1 is equal to c. Well, if I know that 1 is equal to c, I can come over here and solve for a. So then I know that 13 equals 7a minus 1. If I add that 1 over, I get 14 is equal to 7a. So I know a is going to be equal to 2. And then I can take my last equation right here, that a plus b is 1. If I know that a is going to be equal to 2, I can say that 1 equals 2 plus b, so that b is equal to negative 1. Then I need to go ahead and write my final answer by substituting everything back in again. So I'm going to substitute the a in, and I get 2 over x minus 1, plus the b goes in, so I have negative 1 times x, which is negative x, plus my c value, which is 1, over that quadratic, which is x squared minus x plus 7. And that's my final answer. I would like you to try this, which is coming up on the next page. So go ahead and pause it, unpause it when you're ready to check your answer. If you did the try this correctly, you should have gotten an answer of 5 over x plus 2 plus negative 3x minus 4 over x squared plus 2x plus 9. If you have any questions, let me know.